Hi, I'm Randall Heyman, a university academic. During the coronavirus outbreak, I'm making videos for lecturers, tutors, high school and primary school teachers, students, grandparents, parents, and anybody else that's interested with various mathematical problems and concepts. So if you'd like me to make a video for either you or your students, please comment below this video or any of my videos or drop me an email. So up on the screen, Euler's theorem, the very beautiful Euler's theorem, which we're clocking through. At this stage, we're going through it line by line. So we're up to the sentence that you can see there that says, let K be the order of R and let phi M equal HK. So let's explain that. I'll just share my whiteboard. Okay, so you can see here we've got Euler's theorem. That's what we're about. This is the sentence that we had in the last video. And this was the theorem that it referred to. But this video concerns the next sentence, which is this: let K be the order of R and let phi of M equal H times K. So it's not a terribly much to say here. It's just a little bit confusing. So we know that the order of the set G is, well, it's not G really, is it? It's the order of the set, what was it, X, such that 1 is less than X is less than or equal to M, where the GCD of X and M is equal to 1. And we had the multiplication modulo M, and that was actually the group. Whoops. Let's write the group symbol there, and I'll just put here multiplication mod M. Okay, so in the language of up here, theorem 10.15, this here is the set G. Okay, so we know that the order is of this group. So actually, order of the group. So I'm just trying to explain this really fully. Order of the group, I went through this in the last video, is phi of M. That's the definition, basically the definition of phi of M. And we know, so what they're saying up here is let K be the order of R. Remember the order of the element, we discussed that in the last video. It's a different, we're using order to mean something different here. So K, oh, actually, let's write it this way to make it consistent with what I just wrote. So we've got this point here, and we've got the next point. The order of R, which is an element of the group, is K. And then the next point is that K, the order, divides, it's a factor of, divides that. And so, well, we don't need all this stuff here. We had that previously, didn't we? Okay, so what do we conclude? So phi of M, if K divides phi of M, so phi of M must equal K times H for some H. I mean, that's what it means. If we say something divides something else, well, it means that if you multiply it by something, you'll get the number that we're concerned with. So remember in the last video, I think we had phi of M, M was 10, we had phi of M equals 4. I'll just write that there, we had 4. And remember here we had the order, sometimes it was 1, sometimes it was 2, sometimes it was 4, but if the order was 2, so if K equals 2, then we would have h equals 2. That's all it's saying. That's all it's saying. So if we now look, if we just cast our eyes back to the sentence here that we're trying to come to terms with up here, let k be the order of r and let 5m equal h times k. So he's sort of collapsing it into a few concepts into one thing. He's saying let k be the order of r, and since we know that r is a factor of phi of m, it follows that phi of m is equal to h times k. So that's that sentence there. In the next video, we'll do the final sentence where it all comes together. And then you can walk away knowing that you understand the beautiful Euler's theorem. Any questions on what I've written, please drop me a comment on this or any of my videos, or send me an email to coronahelpmathematics@gmail.com.